Good morning, 8th grade. Today we are going to be working on module 11.7, and this one is solving systems of linear and quadratic equations. So we've done systems of equations before, and now we are looking at systems of linear and quadratic equations together. And so let's look at our learning target. I can solve systems of linear and quadratic equations by graphing. And I can also solve systems of linear and quadratic equations by using algebraic methods. So there are two ways that I am going to show you today how to solve systems of equations. So one is by graphing and the other one is algebraically. All right. So if we are graphing, if we are using steps to solve systems of linear and quadratic equations by graphing, there are certain steps involved. So it's the first step. We are going to graph the quadratic function. Then we are going to graph the linear function. And then we are going to see where are the points of intersection. So as we've done before, with the other linear equations, when we had done that, we know that where the graphs are intersecting, that is the solution. And if there's no intersection, there is no solution. And so we are going to find the points of intersection, and then we are going to substitute the values in the original equation to check our work. So let's go ahead and we are going to work on a problem on the whiteboard. And so here is, a set that I have put together. As you can see, the first one, the degree is 2. So that one is my quadratic equation. My second one, as I can see, the degree is 1. So therefore, and we're talking about the leading, the variable. So here I can see that my degree is 1. So the second one is linear. Okay, so the linear one is always very easy to graph. So I'm just going to show you based on what I have. So I'm going to graph it first. So I'm going to graph the linear one. So if I am looking at my linear function over there, okay, but the first thing, of course, I can also do one more thing. I can just go ahead and I know what your rise and run, etc. is. If I'm looking at my linear one, what is my slope? So this one, because it is in the format, y is equal to mx plus b, if you remember from the past. And so if we already have that, since we have y is equal to mx plus b, m is my slope, so this is going to be rise over run. So this is 2 over 1. So the change in y is 2 and the change in x is 1, right? And then let's look at what is this is my y-intercept. This is my y-intercept. Okay, so I'm going to go ahead and I'm going to plot my linear equation, and let me use, I can use red for that. Okay. So I know that my y-intercept is how much? It is 2. So 0, 2, that is my y-intercept. And then it is saying that it is going to rise 2 and the run is 1. So I go 1, 2, 1. I'm just putting all the points based on the linear equation. 1, 2, 1. 1, 2, 1. 1, 2, 1, and that's what's going on. Same thing here. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. There we go. All right. Now once I have this, I am just connecting this with a straight line. There we go. So here is my y is equal to 2x plus 2 line. Okay, that is my linear equation, as you can see. Now, let's look at the quadratic one. Right, so let's look at, I am going to put that here, my quadratic one, okay? And let me just push this back so you can see properly. All right, so y is equal to x squared plus 4x minus 1. So first thing with the quadratic, what am I supposed to do? I am going to find the axis of symmetry. And so to find my axis of symmetry, I am going to say that my, it's going to be what? It's going to be negative. So we know that this is A is 1, B is 4, and then that's what I need. Right? And then C is -1 in this case, but we're not going to need this right now. So to find the axis of symmetry, I am going to do opposite of B, so that means -b over 2a, which gives me -4 over 2 times a is 1. So I get my axis of symmetry as -4 divided by +2, which is going to be -2. Right? So since this is my axis of symmetry, that's the first thing I always like to plot on the graph. So I know where the vertex is going to fall. So let me use a different color for axis of symmetry. Let me go ahead and use blue. And we said the axis of symmetry is -2. So this is my axis of symmetry. I know that my vertex is going to fall on this line over here. Okay? So this is my axis of symmetry. Next, I'm going to go ahead and I am going to find the vertex. Okay? If I'm trying to find the vertex, I already have what is x, which is what? -2. Okay, my x is -2. So I'm trying to find what is my y. And so then that way, first and foremost, I can see up here it's positive. So I know that my graph, my parabola is going to be facing upwards. Okay, so let's go ahead and substitute the value into the equation for my y is equal to x squared plus 4x minus 1. So into this, I am going to substitute this value. So y is equal to x squared. So what is x squared? Is going to be -2 squared, right? And then I have plus 4 times -2 minus 1. So now I have just substituted the value of this because axis of symmetry is nothing but x, right? So I have substituted the values of x in here. And so then I get y is equal to 4 plus, what is 4 times -2? So this is going to give me my -8 minus 1. And so when I solve this, I get, this is going to give me y is equal to 4 plus -8 minus 1. I'm going to end up with -5. Okay, so therefore my y value is -5. So that is where my vertex is going to be. So I'm going to go to -2 and I'm going to go to -5, and here is my vertex of my parabola. Okay, and then the next thing that I'm going to go ahead and do is I'm going to find the y-intercept for this. So the y-intercept means my x, that's telling me where the y is crossing over. Okay, so what is my x going to be in that case? Is going to be 0. So it's going to be 0, and let's find what this is. So I'm going to take the original equation once again, and I have 0 squared plus 4 times 0 minus 1 is equal to what the y-intercept is going to be, right? So this gives me -1 or -1 is equal to my y, so I have -1. So what is my y-intercept now? It is 0, negative 1. So I am going to go ahead and I'm going to plot that. So I have 0, negative 1, and this is my y-intercept. Now, notice that this is away from the axis of symmetry. So I've got to make it symmetric on the other side also. So I'm going to do 1, 2, and I'm going to go 2 to the left. All right? And then the next thing, I am going to go ahead and I am going to use another point to find more points on this parabola. So let's say since this is 0, let me find what happens when I say x is equal to 1. So if I say x is equal to 1, I'm going to use that original equation where y is equal to x squared plus 4x minus 1, and I'm going to substitute the 1 into this equation. So let's see what happens. What is y going to be if my x is 1? So we're trying to find what is y here. Okay? So this is 1 squared plus 4 times 1 minus 1 is equal to 5 minus 1. And so y is equal to 4. So what is my ordered pair? Is 1, 4. Okay? So I'm going to go over here 1 and I have 4, which is here. So as you can see, there is an overlap. Now, let's look at this. How far is it from the axis of symmetry? 1, 2, 3. So I'm going to go same thing on the left. 1, 2, 3. Here we go. All right? And then I am going to take this parabola and this is what I'm doing. Okay? So let's look at this. What do I see that is overlapping in the graph? I can see that there are 2 points that are overlapping. Okay? One is over here, and this one is going to be my 1 and 4. Here is one of the overlapping. And then the second one that I'm noticing is over here. And what is this one? Negative 3, negative 4. Negative 3, negative 4. Okay? So when I look at that, that is definitely going to be my solution because the points of intersection, the graphs are intersecting at these two. So what is my solution? My solutions are 1 and 4 and negative 3, negative 4. Okay, and that's how we just use the graph to see where the system of equations, the quadratic and the linear function, what is a solution to that. All right, let's recap really quick before we move on to algebraic. And so this is saying solve a system of linear and quadratic equations graphically. And we are looking at the graphs of f of x is negative 2x plus 3. So looking at that, that is a degree 1 polynomial. So therefore, I know that this one is a linear equation because the degree is 1. And the second one, the degree is 2 with the x squared. The degree is 2, so I know that that is a quadratic equation. So we are solving the system, and we're going to look at the graph, and we're going to complete the ordered pairs to represent each situation. So the first one is saying f of x is equal to 0, means where is the x-intercept? Okay, so since f of x is the linear equation, as the straight line, and that's what I'm looking at first. So let's look at where is my x-intercept? Where is the line crossing the x-axis? And that is happening over here. Okay, so if I look at this, this is definitely my x is 1 and 5/10, right? So therefore, my ordered pair in this situation is 1 and 5/10 and 0 because y is 0. All right, now let's look at the g of x, and we are looking at where is the 0 again means what? We are solving for zeros, which are the x-intercepts. right? So g of x is my quadratic equation. So I'm going to look at the blue line. So it's intersecting. There are two solutions. It is intersecting here and it is intersecting here. So therefore, what are the 2 points? I have -1, 0. That's my first one, right? And what is my second one? This is 5, 0. So here are my graph, the x-intercepts of the graph. Now let's look at what is the solution to this one. And that is f of x is equal to g of x. And solution means where is the graph intersecting, the two equations intersecting each other. So I have one which is here. So this is my solution. And this is what? This is going to give me -2, and in the middle this would be 7. So I have -2, 7. And in this case, it is here, okay, which is going to be, this is 4, and then here in the middle is going to be -5. So 4, -5. And these are the two solutions. So I'm just going to write this here, -2, 7, and I have 4, -5. So just by looking at graphs, I can see where the x-intercepts for both are, and then I can see where is the graph intersecting, the two lines intersecting each other, the parabola in this case. The parabola with the linear equation. Where are those graphs intersecting? And wherever they are, that is the solution. If they do not intersect, I can have a situation like this, for example. Let's say this line was not there. There was a line like this. As you can see, there was no intersection going on between the parabola and that line. So then in that case, it would be no solution. But as of now, of course, we have those two solutions that I just showed you. All right. So now let's go ahead and solve a system of linear and quadratic equations algebraically. So if we are solving a system of linear and quadratic equations algebraically, there are certain steps that we need to follow. Okay, so the step one, the first step, we are going to solve the equations for y. We are going to substitute one expression for y in the other equation. Next step, we are going to solve for x. We are going to substitute in step 4, we are going to substitute the x value of values in either equation, solve for y, and then we are going to graph the equations. So those are the steps that we need to follow when we are solving the equation algebraically. So again, we are going to solve it for y, substitute the value of y, this is equal to this. We are going to solve for x after that. We are then going to substitute the x values in either equation to solve for y, and then we are going to graph it. So let me go ahead and do all the calculations over here on my whiteboard, and then for graphing we will go to my smartboard in a minute. Okay, so all right, so here is my system of equations. I can see with the second degree on the top, that's quadratic, and in this one it's going to be linear because that's the first degree. So the first thing that I need to do is to solve for y. The quadratic one is already solved for y. Now I'm going to take the linear and I'm going to solve that one also for y. So if I do y is equal to minus x, right? So it's going to be -x plus 3. So now I have this one solved for y. Now I'm going to put both of them together. There are several methods to do this, but I'm just going to teach you the substitution method right now. Okay, so we have y is equal to x squared minus 2x minus 3. And this one it's saying y is equal to -x plus 3. So basically, I can use system of elimination also, but however, let me show you substitution. So what it's telling me that if y is this and y is this, that means these two are equal. These two are equal because it's telling me the value of y is this, but the value of y is also this. So what I'm going to go ahead and do is I'm going to substitute the value of that into, because it's saying y is equal to whatever. All right. So I am going to go ahead and do, let me write it here. X squared minus 2x minus 3 is telling me this is equal to this because y is the same. So negative x plus 3. Okay, so now once I've written it out in this form, I am going to change this to the quadratic format. Okay, and so let's go ahead and start with adding x to both sides. Okay, and that gives me this, and I have 3 is equal to, so I have x squared, negative 2x and plus x, and that is opposite signs. So this leaves me with just minus x, and then I have minus 3. Then I'm going to take the 3 to the other side. So I'm going to have to subtract 3 from both sides, and I am left with is equal to 0, and I get x squared minus x minus 6. All right, now once I have this, I am going to go ahead and I am going to factor. Okay, and so when I do that, what am I doing? I am just going to look at this. If I have negative 6, what factor? So for 6, if I can have 1 times 6, I can have 2 times 3. And so since this is negative, that means both of them, the factors are going to have the opposite signs. So, and I also need to get to negative 1x. So if I do negative 3 and I do positive 2, I am going to get, because what is 3 minus negative 3 plus 2? I get negative 1, so that makes sense. And what is positive 2 times negative 3? I get negative 6, right? So if I was factoring this out, I have taught you the area method. I'm just going to go ahead and do that here. Okay, so first number goes in the first box, last number goes in the last box, and then I've taken my 2x and I've taken my negative 3x. Okay, pull out the greatest common factor, which is x, and I get x here and I get 2 here, and then x times negative 3, and then 2 times negative 3 gives me 6. So what are my factors now? I have x minus 3 and I have x plus 2, right? So I'm going to write that here, x minus 3 and x plus 2, and this is going to give me 0. And then I'm going to use the zero product property, and I know x minus 3 is equal to 0, and my x plus 2 is equal to 0. So then I am going to solve for x, and this is plus 3, and this is plus 3, and I get x is equal to 3, and in this case I get minus 2, and I have x is equal to negative 2. So now I have found what x is, right? So this is not over now because I need to find out what would y be. So I'm going to substitute the x values in either equation now. I'm going to choose the linear one. It's smaller always. So I'm going to go ahead and choose the linear equation, and which is telling me that y is equal to negative x plus 3. So since there are 2 x's, I am going to write this out 2 times because I'm going to have 2 solutions, right? So I'm going to write y is equal to negative x plus 3. Y is equal to negative x plus 3. And then when I am solving it, I am just substituting, because what did I say that x was 3? So in this case, I'm going to use 3 for the first one. Second one, I'm going to use -2. Y is equal to negative, because this is a minus sign, and I have 3 plus 3. So what do I end up with? Y is equal to 0. So my first ordered pair in this case is going to be x is 3, y is 0. So it's telling me what my solutions are. Okay, and then I look at the next one and I say y is equal to, and I have -2, because negative x plus 3. This gives me 2 plus 3, and so y is equal to 5. So here is my other solution, because I'm trying to calculate what would y be. So if this is -2, my y is 5. And I have 2 solutions. That means if I graph it, my graph is going to intersect at 3, 0 and -2, 5. So let's go ahead and look at the graph. I'm just going to graph it. So I'm going to go ahead and graph the linear equation first. That's always simple. As I can see, it's -x, so we are looking at the y is equal to mx plus b format. And so I know that if it's -x, that means my coefficient is -1. So my slope over here, which is m, is going to be my rise over run. Okay, and then what is my y-intercept is 3. Y-intercept is 3. So let's go ahead and graph this. That means my y-intercept is at 0, 3. The negative tells me that my graph is a downward slope. So if I'm saying -1, so we are going 1 down, 1 right. 1 down, 1 right. 1 down, 1 right. Okay, 1, 1. So this is what is happening to my graph. And okay, here we go. Same thing on the other side. And this is my linear equation. Okay, so if I graph this, I just draw that line right across. All right, so this is my linear equation, which is y is equal to -x plus 3. Okay, so I've graphed my linear. Now let's look at my quadratic equation over here, and I am going to go ahead first find the axis of symmetry. And so axis of symmetry is equal to opposite of b over 2a. Okay, and so if I'm doing, what is the opposite of -2? It's going to be 2 over 2 times 1, because my a is 1, my b is -2. And that gives me 2 divided by 2, and I get my axis of symmetry as 1, which is my x is equal to 1. So first thing I always like to do, as you know, is to plot out my axis of symmetry. So here we go. It said 1, so therefore we are going to make this dashed line telling me this is my axis of symmetry. Okay, this is my axis of symmetry. So the parabola is going to be symmetric on both sides of this, and my vertex is going to fall on this line. Next thing I'm going to do is find the vertex. I've already found x, so I am going to find a y. So my x is 1. Let's see what y is going to be. I am going to take the original equation, which is x squared minus 2x minus 3 is equal to y. And so therefore I have 1 squared minus 2 times 1 minus 3. And when I do that, I am going to go ahead and I am going to get -4. Okay, and so this is 1, -4, and that's where my vertex is going to be at. So let me go ahead and I'm going to plot that. Here is my vertex. So this is my vertex of my parabola. And since I can see that this is positive, my parabola is going to be opening upwards. Okay, so then I'm going to go ahead and I am going to find the y-intercept. And for y-intercept, we know x is 0. Y-intercept, we know x is going to be 0. So this is going, let me just put this, 0 squared minus 2 times 0 minus 3. So I get -3. So therefore, my point is 0, -3 for my y-intercept. So here we go, 0, -3. So if this is my y-intercept, on the other side is going to be exactly the same thing. All right, now the next thing we are going to go ahead and do is find another point. And so since 2 is already gone, let's take 3. Okay, so if x is equal to 3, let's see what y is. So we are looking at x squared minus 2x, so x squared minus 2x minus 3. And so since x is what? 3 squared minus 2 times 3 minus 3, I get, what is 3 squared? Is 9 minus 6 minus 3, which is 9 minus 9, which gives me 0. So therefore, my ordered pair is the x-intercept in this case. So look here. So this is where the solution, look how it is meeting. And then and so I am going to go ahead and I had already solved this, and let's go ahead and, just complete the parabola like this. So there you go. Now look, where are they intersecting? So as you can see, I had already calculated this algebraically, and then I put it on the graph. I got the same results. So in the solution, there are 2 sets of solutions in this case, and I have 3, 0, and I have -2, 5. So either way, whether you do it algebraically or you do it graphically, you are going to end up with exactly the same solutions. And we know on a graph where the lines intersect, or the parabola, the 2 lines are, this line and the parabola are intersecting, that's telling me where the solutions are. So it's exactly the same thing, algebraically or graphically. And I use the graph just to confirm that my answers were correct algebraically and to show you further graphing. Okay, so let's go ahead and do another problem. So here's a word problem. We are using system of linear and quadratic equations again. Sales. Bathing suit sales at a clothing store can be modeled by the function y is equal to -x squared plus 12x plus 25. So looking at that, I know that's the quadratic because of the second degree. And gift card sales can be modeled by the function y is equal to 5x plus 7. I can look at that and know that's the linear because of the 1 degree. Where x represents the number of months past January and y represents the total revenue in thousands of dollars. So solve a system of equations algebraically to find the month when the revenue from bathing suit sales is equal to the revenue from gift card sales. Okay, so I'm going to take both of them, and y is equal to this and y is equal to this. That means both of them are equal. So I am just going to go ahead and straight up substitute the values, and I am going to say -x squared plus 12x plus 25 is equal to 5x plus 7. Okay? Next, I am going to add -x squared to each side. I try not to have a negative on this. Try to make your that into a positive if possible. Okay, so I'm going to go ahead and add my -x squared. That would be plus x squared plus x squared. Okay, so I take this off and I'm left with 12x plus 25 is equal to x squared plus 5x plus 7. All right, and so then next I am going to subtract 12x from each side. So let's see where I can solve this. So this is going to be minus 12x, and I'm going to do minus 12x over here. And so I end up with, let me go ahead and write this up there, trying to find some room where I can do this. So I'm left with 25, well, I'll do it here. 25 is equal to, and of course I have my x squared, and then this is minus 12, and that is plus 5. So we are going to subtract the two, and I get minus 7x, right? Minus 7x, and then I have plus 7. Next, I am going to subtract 25 from both sides. So if I do minus 25 here, I'm left with 0 is equal to x squared minus 7x, and then these are opposite signs, so I subtract, and 25 minus 7, I am going to get minus 18. Okay, then I'm going to factor this out, and you know how to do that based on my lovely area method. So you take the first thing, which is x squared up here, last one goes here, negative 18, and then let's factor out 18. I'm factoring 18. I can get 1 times 18, I can get 2 times 9, but I am trying to get over here to negative 7, so that one makes sense, and this is going to be negative 9 and positive 2. Because what is that going to give me? That will give me negative 7. And multiplying the inverse sign is going to give me negative 18. Okay? So this is 2x and this is negative 9x. Pull out the factor here, greatest common factor. I get x and I get 2. And I get negative 9. And then I know that 2 times negative 9 is this. So what are my factors now? I have 0 is equal to my x minus 9, and I have x plus 2. Okay, these are my factors. I'm going to use the zero product property, and I'm going to say x minus 9 is equal to 0, so x is equal to 9. And the other one, I'm going to do x plus 2 is equal to 0, so x is equal to negative 2. So to save us time, I just went ahead and I substituted the values of x into my linear equation, because I've got to substitute that into either of the equations, and then I went and solved for y. So if when I put in my value of x is equal to 9 into 5x plus 7, 5 times 9 plus 7, I get 52. So my ordered pair would be 9, 52. The negative values are not going to work for this situation. All right, and so, but still, I went ahead and solved it, and if I do 5x plus 7, I get y is equal to negative 3. Okay, so let's talk about why I'm saying only positive values for this situation. But this is how the calculations are done, and as I already said, we have 952. That is my solution where my graph is going to intersect. So I'm going to go ahead and show you the graph, which has already been made out, and so we know this is where, which is the solution for that graph. So let me go ahead and show you that. So here you go, and I just told you that my solution was 952. So look, 9, and here is 52. So that is my solution over here. We can see the graph is, both the lines are intersecting. The parabola and the linear equation, in this case, both of them are intersecting over there. So because the expressions are equivalent when x is equal to 9, the revenue of bathing suit sales and gift card sales is equal to 9 months past January or in October. And then, of course, this is the graphing, but we are not going to have negative months or, and stuff like that. So that is why in this case, my solution is going to be only my first quadrant. So it is positive. Okay? So that's how basically we work on solving linear and quadratic equations. Linear, if you're graphing it, linear is like super easy based on your y is equal to mx plus b format, where you know your slope, you know your y-intercept, and then you just do the rise over run and you just graph your linear equation. For quadratic, of course, you have to find the axis of symmetry, the vertex, y-intercept, and another point, and then graph it. And where the two graphs are intersecting, the linear and the quadratic lines are intersecting, that is, or you can say parabola with the straight line are intersecting, that is where your solution is. Now, for some reason, if they do not intersect, there will be no solution. We can also do it algebraically, where we are substituting the values for y, and then after that, of course, we are going to solve for x, and then we have got to put that x back into one of the equations to find the ordered pairs or the solutions in this case. And then we can, of course, graph it to check if the solutions are correct or not. And that is module 11.7, solving systems of linear and quadratic equations, graphically and algebraically. Have a great day, everyone.